Our class today with recitation of Kitab Al-Fatihah. Okay, so today we will talk about polymers. So first we go straight to the definition of the polymers first, yeah. So let's go for the definition of polymers. Definition of polymers, huh? So poly, the poly from the word polymers come from the Greek word which is mean many. So you know that's a poly is is many, and mers is basically what we call the part. So polymers meaning that many part. Okay. So if you want to if people ask you to define what is polymer, you can say it's a substance that's composed of many repeating unit, because this many is basically stand for many repeating unit. This part. So a substance that compose of many repeating unit. Okay. Typically, so this what we call this repeating unit typically is a molecule. It's a very large molecule, or we can call it a macromolecule. Okay, so that is basically the definition of polymer. For example, let's say if I bring you here, and then I make this thing like this. So if let's say you can see this thing, this paper clip, so that paper clip, saya buat macam ni, saya nak kecilkan sikit, banyak guna ruang ni. Okay, like this. Okay, so this paper clip, you can view this one paper clip as a monomer. Okay, so one unit we call it monomer. One unit part is we call it as a monomer. So this thing we call it as monomer. And when you combine this together like this, then you get the two this, like we combine together, and then you get something that is bigger like this, long like that. So that is sort of like analogy of polymer lah. So if you look this paper clip, you have this round long paper clip. So this is one type of this is what we call one polymer lah. But if you have another paper clip like this, something like what we call this triangle paper clip, so there is another what we call another polymer, because the monomer is different. Okay, so depending on the what we call the repeating unit, the monomer itself, the name for the polymer will be different. Okay, but this paper clip, this just for analogy, because this paper clip itself is metal. You know metal is not polymer, because metal, the atom inside metal is like so for example, this just for analogy. So I just put you a paper clip. I put here paper clip analogy. So you cannot say this is a paper clip itself is a monomer polymer, because inside this the atom for example, this is a stainless steel. So you have the ferrum and also the carbon. So the atom of especially the ferrum, the iron, they are sort of like for example, inside the, if you look under the microscope, the atom sort of like attached like this. So this, if you look here, this thing is a ferrum atom. So this is atom, meaning that the element itself, the element ferrum, the atom of the ferrum, the iron inside the metal. But when we talk about the polymer, it's not the element, it's not the atom, it's the what we call, it's the this molecule. And molecule is not an element, it's combination of the element. For example, water molecule. Water molecule is H2O is basically like this. You have O like that, and then you have the normally this red color. Normally you have this thing, the oxygen, and then you have the what we call the hydrogen. So that's what we call the molecule. The atom is this individual. The red one is the oxygen, the black one is the hydrogen. So for metal, we will not consider it as a polymer, even though inside the metal you can see that the atom sort of like arranged like like a chain, but it's not connected. It's not like it's not polymer because of when you have the element, we don't call it a polymer. It's more like just an element. Okay, so that's the difference. So you need to make sure it's a molecule. Most often it's a molecule, not an atom or not an element. Okay, so that is the polymer. The definition of polymer: a substance that composed of many repeating units. Okay, so now we go for the type of what we call the type of let me remove this. Let me go here first. So that is the definition of the polymer. So now we go to the type of the polymer. So I go then down. So type of polymer. Okay. So normally when you want to classify the polymer, you can classify it either by type, either it's natural or synthetic. So let me go here first. Let's look on the natural polymer. Natural polymer first. Okay, natural polymer first. Okay, natural polymer normally it derive from either the plant, this plant, and also the animal. So let me draw the elephant first. Okay, so that's elephant. So either plant or the what we call this, either plant or the animal. So for example, wood. For example, from the plant, for example, this is like for example wood. Wood. Okay, so the wood, the name of the polymer inside the wood. Okay, the wood itself is there are a lot of things. So inside the wood you have this what we call the bark of the tree, the trunk of the tree, and then you have the leaf like that. Oh, this is not like nice color. So let me draw like this. Okay, and then you have something like this. Regardless whether you take it from the leaf or from the tree, you can find the same the polymer, which what we call the cellulose. So inside this or inside the what we call inside the inside the bark of the tree or inside the leaf itself, you will find this structural polymer called the cellulose. If you see under the microscope, you take the leaf, see under the microscope, you see something like this. Something like this, and then you have the nucleus in the middle like that, and then what we call inside this cell wall. So this what we call the cell wall. The cell wall of the cellulose, you can find the cellulose inside that. So this and the polymer, as you can see before, is more like a long chain. So you can see if you try to sort of like take the very powerful microscope here, you can see the chain of the cellulose more like this lah. Okay, so that is the cellulose. And you can also see from the paper, for example, from the paper here, from the any A4 paper, if you try to what we call the tear the paper, you can see very small fiber. So that fiber is cellulose. It's a bundle of cellulose. Cellulose itself is made from this thing. From the cellulose itself is made from the, because I need to relate with your organic chemistry, because this course is basically material science for chemical engineer. So when there are chemistry there, I need to go a little bit deeper lah. It's not like a typical material science. I need to go more on a chemical. So inside the cellulose itself, the cellulose, what does it mean by cellulose is you have glucose. You know glucose, right? So the glucose is something like this. So it's something like this lah. This is glucose. You have this OH. This is OH. This is C, and then this is OH, and then you have this, and then you have this. Okay. So this, what we call, this one thing is a monomer of the cellulose. This thing is a glucose. Okay, imagine like this thing, like this paper clip. This one paper clip, you imagine it as a glucose. But when you make it long like this, you combine the glucose together, so then you get, the name become cellulose. Okay, the name become cellulose. And that is the one that you see when you pierce the paper, you see that the fiber like that. So that is the cellulose itself. But that cellulose is a bundle. I mean, the cellulose, by definition, is just this, the chain of the glucose. Okay, but of course, it's a molecule. It's so small. When you see on the paper, you can see like the what we call the fiber. That is basically a bundle of many cellulose. Okay, so this is glucose. Okay, so the cellulose, when you want to draw the polymer molecule, you don't just you for example, you can draw another this like this, and so on. You can draw like this, so on, meaning that you make a chain and so on, but it's so tedious. So normally what people do is that they just do like this, put the monomer like that, and then they put like a bracket, and then they put the end here. The end dictate how many. I mean, the end is just like the repetition lah. So you have like the glucose and then many end. So this is how people denote the monomer in a what we call in a polymer. So just to know, okay, if let's say you see this thing, you know this is cellulose, not glucose. The glucose is this. Okay, the glucose itself, I mean, this is actually not glucose. The real glucose, the real structure of glucose is, you can see, right? It's like this, oxygen, something like this, It's same, OH. Let me draw carefully lah, so I don't want to confuse you. So you have something like this, you have OH, and then you have OH. Tak cantik lah, because let me draw carefully, 0 like that. Okay, so you have OH, and then you have OH here, and then you have this OH, and then you have OH here, and then you have OH here. The orientation will differ lah. Sometimes the orientation OH will be up and down. That's you will learn in organic chemistry. There are reasons for that. Okay, when for example the hydroxyl group, this is what we call hydroxyl group. The one, this OH, the OH, oxygen and hydrogen, we call it hydroxyl group. So normally in cellulose, in glucose, this hydrogen group, the OH on the side here, it can be up and it can be down. Okay, so that's you will learn in detail in your organic chemistry, why is that happen and so on. So this itself is a glucose. This is actual glucose, what we call the glucose molecule structure. When you make the polymer, you break this OH, right? You break this OH, you break the thing. So that's why when I do like this, you don't see the OH. Okay, so by right, this is not glucose lah. It's just like, we call this thing, the everything here, we call it cellulose. Because why? Because the glucose, you need to have like, glucose itself is just one molecule. Okay, they don't have any what we call any combination with other molecule and so on. So it's just one thing. It doesn't combine with others. So when you have this bracket and you have N, meaning that this glucose connected with others, so the structure will be a little bit different. You can see there are no OH, because OH here, it become because if let's say you have OH here, let's say you have another OH here, right? OH here, and let's say there are another OH here, and then there are another OH here. Let me put here. So what happened is basically, this thing, the water will come out. The water, this H2O, okay, the water will come out. Okay, when the water come out, so you can see the bond will become like this. The bond, let me go down. So the bond will become like this. O, and then this big thing, and then this big thing, and then this is O, and then this big thing. The big thing is this lah, the one that you see just now. So that is basically the linkage. So the linkage, we call it glycosidic bond. Glycosidic bond. Okay. So basically, this is how the glucose connect with another glucose. Is connected with this O, and how this O bridge happen is because of this condensation of this H2O. You have this HO. You have 2 H, you have 1 O, you have water, right? So water coming out, so it combine, and then you get this linkage, and then the thing repeat again and again. You get the long chain of the glucose that is connected with each other. You get cellulose. So that is one type of a natural polymer lah. So cellulose is natural polymer. Even you go to the leaf of the tree, it's also the same, cellulose and so on. Okay, so that is one example of natural polymer. So what else? The example of natural polymer. So let me put here number 1, wood number 1. Okay, let go down. So the second example of natural polymer is your hair. Okay, your hair, animal hair, wool. For animal we call it wool. For sheep lah, sheep we call it wool. And then you have skin. Even skin also is a polymer. Okay, so let me put this color so easy for you to differentiate later on. Okay, so here, if you look here, what make this sort of wood polymer? Because you combine cellulose together. So in hair is different. This thing, the glucose, we call it carbohydrate. We call it carbohydrate. Carbohydrate. Okay, so you have carbohydrate combined together. But for hair, wool and skin, they don't use carbohydrate. Carbohydrate is basically sugar lah. Carbohydrate, you have carbon and also hydrate. Hydrate is water lah. Carbo, C and the OH. But for the hair and wool and skin, what combine them together is a protein. It's a protein. So basically, the basic unit is protein. Protein. And you know what make protein? Protein is because protein, the basic unit for the protein is amino acid. Amino acid. So basically your hair, the protein they call for hair, your human hair or what we call human hair or the sheep. Let me draw a sheep. Okay, so this is the sheep. So this is sheep. So this is human hair. Okay, so these two things, they have the protein that make them is they call it keratin. Keratin. The same thing also the thing that make your nail and so on. So we call it keratin. And keratin is a protein. Keratin is a protein, and protein, the building block for the protein is amino acid. So basically, if you go under microscope, you will see this. The chain is like this. Amino acid, we call it AA lah. To make life easy, we put it AA, and then you combine with another AA, you combine with another AA, you combine with another AA. So amino acid. Amino acid. So basically, when you amino acid combine together, you get protein. Okay, and keratin is one type of the name of keratin. And for your skin, you have, for example, you have skin. So skin. So the protein for the skin, we call it collagen. Collagen. Okay, you know collagen. So it's the same thing, but different AA lah, different amino acid. They don't use the same amino acid as what make up the hair, but you have a different amino acid lah, different amino acid. Okay. And this amino acid, it doesn't mean that it's a little bit different because amino acid, the one that is combined this thing, for example, this number 1, this number 2, this number 3, and this number 4. This 1, 2, 3, 4 might be different. Okay, might be different. For example, this amino acid 1, amino acid 2, amino acid 3, amino acid 4. So at the end of the day, you might get something like this. 1 to 4, you get something like this lah. You get something like this. 1 to 4, and then combine another 1 to 4. And then combine together 1 to 4. Sometimes it can be like this, meaning that you have this block polymer, block like that. Okay, sometimes you have the same amino acid, but most of the time you don't have the same amino acid. They have like a block in block. For example, 1 to 4, one block, and then they repeat again. 1 to 4, repeat again. So it's the motif. It doesn't mean that you need to have only one sort of like one substance like the carbohydrate here. For example, this carbohydrate, you only need to have the glucose. For each repeat is a glucose. Glucose is the repeating unit. But for protein, more often than not, it's not like that. It normally it's like a block. For example, you have 1 to 4, same, and then repeat again 1 to 4, 1 to 4, 1 to 4. So that is basically the natural polymer that make your hair, wool, and skin. Okay. And maybe the last thing that I can say about the natural polymer, example of natural polymer. So this we call it number 2. So let's go number 3. So number 3, The natural polymer example of natural polymer is what we call latex. Okay, latex. So latex. Okay, the latex you know from the rubber tree. So you just scotch this thing. So this rubber tree, and then you get sort of like the latex lah. So you have this milky sap So getah sekrap. Okay, so this latex is not from amino acid. The monomer, the building block for this milky sap or latex is not carbohydrate, is not also amino acid. It's different. So this come from what we call the monomer is basically isoprene. Okay, isoprene. The isoprene have this structure like this. Isoprene have a structure like this. Okay, you need to familiar with this chemical structure and so on, because you are under the umbrella of chemical engineer. So at least you need to familiar with this thing. Start familiar with this thing lah. So this is what we call the isoprene. Let me draw carefully lah. So you have something double bond, and then you have single bond, you have double bond here, and then you have iso. This another single bond like that. Okay. So this is isoprene. Okay. So when you have this isoprene combine again and again, you get a latex. Okay. The latex is basically something like for example a glove. Latex glove. For example, this glove. This glove. Okay. This glove, whatever glove. Normally the white glove, they are made from the latex, but not necessarily. Not necessarily. Sometimes you see the blue glove. Okay, the blue glove is not latex. Normally they call it nitrile, N-I-T-R-I-L-E, nitrile glove. Okay, this is latex glove. Normally when you go to the medical hospital or whatever, they use this white glove. This is latex glove. They make from the latex. Okay, but some people have allergy for the latex, so that's why some people when you buy the glove, sometimes they show on the box latex free, because some people have the allergic to the latex. Okay, so that is basically what we call the example of what we call the natural polymer. Okay, in this course, we are not really focused on natural polymer. We are more focused on the synthetic polymer. There are two types. They are natural and synthetic. So natural, I just give you the background. What is this polymer? So at least you know this thing, the glucose, carbohydrate. You know a little bit about cellulose. You know about glycosidic bond. You know a little bit about creatine. You know about protein, amino acid. You know about latex, and so on. So now we go to our different another type of the polymer. Okay, so another type of polymer is called what we call this synthetic polymer. So let me put like this: synthetic polymer. Okay, so when we learn this material science, most often than not, we are more focusing on the synthetic polymer. Okay, synthetic polymer. So this synthetic polymer is basically this includes familiar plastic lah. Familiar plastic. So the plastic is polymer lah. So it derived. So this plastic, the one that you see around you, is derived from what we call, from what? Petroleum. Derived from petroleum. From petroleum petroleum oil. Okay. So this petroleum oil, this petroleum oil is basically, if you look in its chemical makeup, is made of the hydrocarbon, meaning that inside the petroleum you have mostly carbon and hydrogen, mostly that. So you have carbon and hydrogen, and this become the raw material. Because if you, it's like Lego. The raw material, Lego block. The Lego block is a raw. Imagine the Lego block is a raw material. You can have a Lego block, and then you can create a lot of other things. You can create a lot of different objects from that. So this carbon and hydrogen become the raw material to make the plastic. Okay. So in fact, when you study, are you taking the organic chemistry now? Ni siapa ni? Siapa hilang ni? Who is this? Asri Asri, where are you? Okay, Nasrul. When you are you taking the organic chemistry now?
Yes, okay.
Okay, so organic chemistry, when you learn about organic chemistry, is basically the entire organic chemistry. The entire course chemistry, the entire course is about this hydrocarbon, the study of hydrocarbon. Okay, and for chemical engineer, so this is one of the most important course lah, the organic chemistry, because most of the chemical process that happen in the industry, they use this hydrocarbon or oil as the what we call the building block, the raw material to get this carbon and hydrogen. Okay, so that's organic chemistry. Please pay particular attention on organic chemistry. You should be able, for example, I show this picture like this thing. You should be able to at least name dates, because in organic chemistry, what you learn is, when first half normally you learn about how to name it. Second half you will learn what the reaction related to this and that, and also you also learn the functional group. For example, when I said before about this OH, right, the OH is a functional group for we call it hydroxyl. So when you have alcohol, most of the alcohol, not all alcohol have this OH group. Okay, so yeah, so organic chemistry, you need to really take care about that thing, because we will come again and again during this course. Okay, so example of what we call this synthetic polymer. We see before for the natural polymer, we see the example of wood, we see the example of hair, wool and skin, and also we see the example of latex. So that's example of what we call the natural polymer. So now we want to see what is the example of this synthetic polymer. So let me go here first. Maybe I want to bring you here. There. Where is Asri? Asri is this Asri or what? Asri is left. Oh, you Ampin
I'm here, sir.
at pin. Oh, so did I forget to pin? I don't know. Oh, okay, I don't know how. Okay, it's okay. So now it's okay. So now let's talk about this synthetic polymer. Around you there are a lot of plastic, but if you take a plastic, let's say around you, whatever you have near you, can you tell me what is that plastic? So there are a lot of type of plastic. So we go one by one. We not go everything because that's too much lah. So maybe we choose only few. So example of synthetic polymer. Okay, first, let's talk about this PET. Okay, PET stand for what? Stand for polyethylene terephthalate. Ni gaji dia. Terephthalate. Itulah. Terephthalate. So what is this PET? Let me bring here lah. Let me bring here a little bit. Because okay, PET, polyethylene terephthalate, meaning that inside this you have what? Inside this thing, you know the poly part, right? Poly meaning that a lot. So the monomer is basically this ethylene, okay, ethylene and terephthalate. Okay, and this ethylene and terephthalate combined together. So the ethylene is basically a simple this thing lah. The ethylene is like this, C and then C. This like H. Ethylene is basically like this lah. Actually, ethylene is this ethylene. Okay, this ethylene. You have double bond and so on. We call it ethylene. Okay, but when you want to combine with something, for example, ethylene here. So let me put in the red color here. When you combine with the terephthalate, normally the double bond will be broken. Because to make another bond, you see here you have this, because this C, normally C is combined with the four bond, right? Not normally, I mean that the carbon will combine with the four bond, have 4 bond. So if in ethylene here, so this is basically ethylene. The basic ethylene is the ethylene, okay? The H meaning that there are 2 carbon, in E and E meaning that you have this double bond. So this ethylene, but when you combine with other thing, more often than not, this carbon bond will be break. The reason why this carbon bond break is because the carbon cannot if you want to make another bond here, you cannot do like this, because now you have carbon have 5 connection, and that is what we call the cannot work lah, cannot work. So that's why when you have a double bond thing, when you combine something, normally that double bond will be break. Okay, so that is basically ethylene. But so let's say we break the thing. Okay, see. Okay, so this thing. So what we call so this, how to combine with terephthalate is basically combined with the ester bond. So when you have the O as a connector, that's ester lah. That's ester. So you have this C, and then you have this O, and you have this O, and then you have this thing. Dah pening ke? Tengok chemical ni. Normally some student when they see this chemical structure, they start to this is so but remember, chemical engineer, you need to be sort of like at ease when you see this chemical structure. You need to sort of like relax, okay, because that is what you choose. The chemical, you imagine this chemical structure is like a Lego lah. So this the terephthalate is basically this thing, the entire thing, the one in blue lah. So this is benzene. This benzene, later on you will learn one functional group called benzene. Benzene, and then you have this C, and then you have O, and then you have something like that. Okay, and then this is maybe like this, O, like this, like that. Okay, so this is basically polyethylene terephthalate monomer. So if I make the what we call the sort of like the bracket, so the bracket will be from here. So let me go here first. The bracket will be from here and from here. Okay, so this thing. Okay, so the bracket there. So you have N here. I put the different color lah. N here. So this is not anymore the ethylene lah. We don't call this ethylene lah, because they just become like one thing. Okay, so this is like a monomer, a repeat unit for the PET, polyethylene terephthalate. Okay, you have these two things, and then repeat again. So PET is basically the most common used plastic lah, and typically you use that for making this thing lah. This what we call the plastic bottle. Most plastic bottle that you can see around the world is made from the PET. This one. Yeah, the colorless ni. Ni PET This is PET. So so example of PET, so I put here lah. Dah terjatuh. So example, example is basically a bottle lah. Can you see that? You can see, right? Bottle, plastic bottle lah. Normal plastic bottle, bottle drink, the normal bottle lah. But if you have a Tupperware, the bottle Tupperware bottle, that's different lah. What I say, a bottle is a normal water bottle lah. Normal water bottle that you see in the sold in commercially. This one, the sound. Okay, so the advantage of this, the properties of this PET is that first, normally I can I put here lah. Put here. So it's colorless. Normally it's colorless, and also have highly flexible. So you can see this is very flexible, very flexible. So you can just picit there. Highly flexible, and also they have this, why they use PET as the what we call as a material, plastic material to make this water bottle, is because it have good moisture and gas barrier. This thing, you have the moisture around you, right? That you have moisture around you, so you need a barrier so that the outside gas cannot enter this thing, cannot enter the water. And also moisture lah, cannot from the vapor, air vapor. So the PET also have this good moisture and gas barrier properties. Okay, so that is one of the advantage of this this thing lah, this PET. Okay, so that is PET. Let's go to the next. So the second example is let's say second example is HDPE, high density polyethylene. So this is basically high density Okay, so the example for this HDPE is basically when you see a milk bottle, something that is translucent, for example like this one, you can see that this thing, besar sangat, macam ni, ni, something like this, you can see something that is rigid, this container. Normally when you buy a milk, okay, milk, susu, normally they put in this HDPE, HDPE. So the you can see the property of the HDPE is quite ni lah. In fact for this bottle, this cap is made from HDPE. Okay, this cap is made from the HDPE. This one is made from the PET. This cap, that's why you can see this cap is have more rigid structure. This cap is from HDPE. Okay, so example. So for example here, example for that is, can you see here? Yeah, you can see here. Example is basically a milk jug. Milk jug. I don't want, because later you don't see there. So this I put here lah. Milk jug. Example is milk jug. And then what we call this container lah. Container. The I call it container. The translucent container lah. Container. Okay. So the thing, the one that is like that. The one that you can see, yes, right? That's translucent lah. So what is all these properties of this HDPE? Okay, so you see this thing, they have, it's a little bit stronger. So it has what we call this high strength to weight. Compare if you use glass. Okay, glass is heavy. When you have plastic, you can have the good strength but still low density. Okay, although they said HDPE, when I said high strength to weight ratio, meaning that when you compare this plastic with other material like glass or metal is strong, glass is strong, but then it's heavy. But this plastic is when it's high density format, is pretty much good lah, and it's rigid, but still lightweight, still not heavy lah. Compare this, if this is a metal, then it's very heavy lah. So that is one of the properties of HDPE lah. It have this high strength to density ratio, and it have this rigid character. Okay, now number 3. So let's see number 3. That the common plastic that you see around you is PVC. Okay, PVC stand for what? PVC stand for polyvinyl chloride. Okay, polyvinyl chloride. Okay, so this, the poly is the one that make, so the monomer is vinyl chloride. Okay, so if you draw that thing, it's basically like this. It's basically you have C, you have ash. It's like ethylene, but instead of all ash, you have chlorine. That's all. And then you have this, and then you have this, and then you have N lah. So that is, you see, just changing one atom in what we call in the repeat unit, you get a totally different thing. So that's a beauty of the chemical engineering. You just change one thing only, and then everything change. Okay, so that is polyvinyl chloride. The example of polyvinyl chloride, what is this? This is the pipe. Normally the pipe that you see, they use this PVC. The normally in the grey color or white color lah. So you look around in your house, when you see the pipe, more often than not, they are made from PVC. Okay, so example here, I put here example is pipes, basically pipes. What is the advantage of this PVC? Characteristic of PVC is that it have this good resistance to corrosion, to solvent and so on. So that's why you use PVC as your what you call choice when you make pipes, because when you eat something, when you drain in the sink, everything goes through this PVC. And because PVC have this good chemical resistance to acid, base, salt, fat, oil, whatsoever, so you can use it for a long time. So that's why people use this. People use this for making pipe and so on. Okay, so that is PVC. So now we go to the next example of the plastic that's commonly used in your life is basically LDPE lah. I just copy this thing, not this thing. Same like before, the one that we discussed before, but in a branch. So this is basically this one. This color. This is basically this one. Okay. Okay. So that is basically. So the example for this LDPE is basically the like normal plastic bag lah. Normal plastic bag that you use for when you go to buying your grocery. They use this plastic bag. This plastic bag is basically made from this low density HDPE lah, LDPE. So example we call, so example is plastic bag. So HDPE, LDPE have this low branching lah. So the properties, let me put here the properties is have more branching than HDPE. Okay, more branching than HDPE. So its intermolecular force is weaker. That's why this thing, this plastic, you can sort of like break easily. Break easily compared to when you have this jug of this thing, you cannot do that lah. So because it's branch, the force between this each chain is weaker, so you can easily broke lah. And also you have this because it have more branching than HDPE, meaning that it have low intermolecular force, meaning that it's less strong. I will continue about this polymer into part 2 later on. Okay, we just now, what we learn now is basically about the type of the polymer, definition, type of polymer, and for the synthetic polymer we just go until 4. I will go until 7, and then we will talk about the mechanical characteristic and so on, chemical characteristic of the polymer and so on in the part 2. Okay, so that is basically for today. So now question time. Question time. So as usual, there will be question time. So let me close this thing and I put this question time. So now it's a question time. Question time. So question number 1. Define polymer.
Iwana.
Okay, Iwana. Iwana first. Because I just hear Iwana sit first. Okay, Iwana.
Polymers are substance that compose of many repeating units known as monomers.
Okay.
Poly means many, mer means parts. So to combine together, polymer means many parts. So yeah, polymer.
Okay, so second question. Okay, Iwana, thank you. Because I need to be fast. Okay, explain about natural polymer. Anyone?
Okay, so
Mukri. Okay, wait, Alif Mukri. Okay. Yeah, explain about natural polymer.
okay, so natural polymer you have plants and animals. So the first is glucose, which is a combination of glucose. Second, from hair, wool, and skin. That contains of protein of collagen. Thirdly, latex, which consists of milky snap, and the monomer of latex is isoprene.
Okay, thank you, Ali Mukri. So the third question, tell me a little bit about polyethylene terephthalate. Ainul first. Ainul what? Because there are two Ainul. Ainul what? Ainul Shafiqah or what? Ainul. You just tell the name. If you want to answer, you just say your name. Because I remember, I heard name only. Ainul Shafiqah. Okay. Tell me about the polyethylene terephthalate.
Polyethylene terephthalate, the example is water, and the characteristic is it is colorless and highly flexible. It also has good moisture or gas barrier.
Colorless and highly
Flexible.
And what else?
It has good moisture and gas barrier.
Good moisture and gas barrier.
barrier.
Okay, for the 4 person in front of me now, okay, tell me about the rest apart from the PET, the rest that we will learn today. Anyone? The 4 among 4 this. Anyone? tell me 3 more apart from PET. Explain about that.
Nasrul.
Nasrul. Okay, Nasrul already take. Okay, Nasrul, tell me.
Okay, first HDPE, which is stand for high density polyethylene, which is derived. For example, which is milk jug and translucent container. The characteristic which is high strength to weight ratio and rigid character. And the second which is PVC, polyvinyl chloride. For example, pipe, and the characteristic which is chemically resistant to acid, base, salt and oil and fat. And the last one which is LDPE, low density polyethylene, which is the characteristic which is more branching than HDPE and low intermolecular forces, which is less than HDPE. And the differences which is between LDPE and HDPE, the arrangement of the what we call the molecule, which is LDPE is more branching rather than HDPE. That's all.
Example for LDPE.
Example for LDPE,
Yeah, example.
plastic
Plastic bag. Plastic bag.
plastic bag that we use in the supermarket.
Okay, thank you all.